Elastic energy is the potential energy stored in an object when it is stretched or compressed, ready to return to its original shape. Let's see some real-life examples to get a better idea of how elastic energy can be observed in different scenarios. Resistance band. Energy stored in a stretched resistance band represents elastic energy. Bow and arrow. Energy stored in the stretched string of a bow is an example of elastic energy. Rubber band. Elastic energy is stored in a stretched rubber band. Stress ball. When the hand presses a stress ball, it stores elastic energy. Pinball. The elastic energy is stored in the spring of a pinball machine when it is pressed. Metal spring. When a metal spring is compressed, it stores elastic energy. Bungee cord. The stretched bungee cord holds elastic energy. Balloon. Elastic energy is stored in the stretched rubber of an inflated balloon. Dart gun. The elastic energy is stored in the stretched spring of a dart gun toy, ready to propel the dart forward when released. Ballpoint pen. The compressed spring inside a retractable ballpoint pen stores elastic energy. So, we've seen examples of elastic energy. Now let's check out the equation and solve one or two related practice problems. The elastic energy equation is commonly expressed as U is equal to half times K delta X square, where U represents elastic potential energy, K is the spring constant, and delta X is the displacement from the equilibrium position. This equation helps calculate elastic potential energy in a system based on the spring constant and displacement from the equilibrium position. Let's work through some practice problems to apply and understand the elastic energy equation. Determine the elastic energy of a rubber band when it is stretched from a length of 0.1 meter to 0.3 meter. Use a spring constant value of K equals 120 Newton per meter. Write down the provided data, apply the values to the formula, and find the elastic energy as needed. We need to determine the elastic energy, so U equals question mark. The initial length is given as x initial equals 0.1 meter, and the final length is given as x final equals 0.3 meter. Therefore, the displacement, delta x, is equal to x final minus x initial, which gives the value as 0.2 meter. Also, the spring constant value is given as Ka equals 120 Newton per meter. When we insert these values into the equation, U is equal to half times K delta X square, the value of U becomes half multiplied by 120 multiplied by 0.2 square. So the final value we will get is U is equal to 2.4 joule. Therefore, the elastic energy of the rubber band is 2.4 joule. Let's take one more practice problem. Calculate the elastic energy stored in a bungee cord that is stretched from its rest length of 0.2 meter to 0.5 meter. The bungee cord has a spring constant of K equals 200 Newton per meter. Note the given information, input the values into the formula, and find the elastic energy as requested. Calculate the elastic energy, so U equals question mark. The initial length of the bungee cord is given as x initial equals 0.2 meter, and the final length is given as x final equals 0.5 meter. So we will write the displacement, delta x is equal to x final minus x initial, and the value we get is 0.3 meter. The value of the spring constant is given as K equals 200 Newton per meter. When we place the given values into the equation U is equal to half times K delta X square, The calculation becomes U equals half multiplied by 200 multiplied by 0.3 square, which further becomes U is equal to 100 multiplied by 0.09, and we get the value of U as 9 joule. Hence, the elastic energy stored in the bungee cord is 9 joule. So, that's elastic energy. If you found this quick overview informative, don't forget to hit the like button, share the video, and subscribe to the channel.